Hi, I'm going to give you a lesson now on how to write a conclusion. You know, you have the science lab write-up sort of procedure where there's question, hypothesis, data, that. Um, well, in the conclusion, we'd like you to use a particular kind of format. You might even be using the same format in like English language arts. That's actually pretty cool because it's a really nice format. The thing is, sometimes when, people, human beings, grown-ups, whether you're like a kid in middle school or grown up, and you're asked to give a conclusion, they just throw ideas out there. It's like, oh, I think that this is what happened, and blah, blah, blah. Well, try to put it a little more clearly, where you make a clear statement of what it is, give the evidence that backs it up, and then the reasoning that connects that evidence to that claim. Okay, this is something that's dearly needed in our democratic society, as well as, good, clear thinking skills. And so we're going to have you do this all year long. So in science class, CER, that's what it's there. Get a piece of paper, write down anything that's written in white, okay? And so CER, that's the title of it. And C stands for claim. You want to make a claim. You want to make a clear statement of what the answer to the question is. So a clear and concise statement of your conclusion, okay? The answer to the question that you have. Concise, by the way, means short. It doesn't have to be giant long. Just get to the point. Say it in a clear way, right? For example, for pendulum lab number 1, a clear statement would be the distance it swings. Let me even start that over. I started making a mistake and used a pronoun. The distance what swings? Okay? It should be like this. The distance a pendulum swings does not affect how many times it swings per minute. That's a clear, concise statement. Okay? You want to avoid clutter? Remember, if it's white, you got to write. If it's yellow, you can mellow. So don't have to write the yellow parts. But avoid clutter. What I mean by that is you don't have to say, I think in our experiment we probably came up with, what seems to be happening is that, maybe it's sort of like, you don't have to have all that stuff. Just get to the point and say it, right? Avoid pronouns. Now that's a mistake I just started to make. And sometimes it takes some practice. Don't say it. Say what it is. Use the word. The truth is you don't really save any space by saying it instead of the pendulum. I mean, maybe it's a little shorter, but avoid pronouns. It, he, she, they. Use the word you have in mind instead of saying, it swings less. What? You know what you mean, but nobody else knows what you mean. The pendulum swings fewer times per minute would be a way to say that. So get to the point and say your conclusion clearly, okay? Second part, C stands for claim. What's E stands for? What's the E stand for? The answer is evidence. Okay, so evidence is you want to basically list your data. You want to give the evidence for it. Now in social studies, you'll be giving evidence like, I don't know, the civilization of Mesopotamia was an advanced civilization. And your evidence might be clay tablets that show writing. And the Code of Hammurabi shows they had written laws. And you might be giving evidence. In science, you'll probably be giving evidence of your data, right? And in this case, use the numbers. Every time you have the 8th grade science test since the year 2000, they always have kids write conclusions, and you don't score well on that standardized test unless you use the actual numbers. I've been through several trainings about how they grade them, and use the numbers. Now, you don't have to have all the data. You don't have to write every single number. Like, for example, with the pendulum lab number 1, you don't have to write all 4 swings. What you have, just put the average. And you know what? Maybe you could even get away with just saying the one for the shortest swing and the one for the longest swing. Or you could say all 3 in this case. But it doesn't have to be all the data, just the summary. Get to the important stuff that leads to the conclusion, okay? So just state what the averages are and give the actual numbers that are in your data, okay? And so that's C, E, and what does R stand for? Say it. What does it stand for? Reasoning. Okay, so reasoning, sometimes this is the hardest part. really, because you might be like, well, it's obvious how that data would lead to that conclusion. It's obvious to you. But this is actually the part where you use your brain, right? Where you think about your thinking and you're thinking, what kind of assumptions am I making that would lead to that conclusion, right? So explain the reasoning. So the reasoning explains how the data leads to the claim. Now, I'm not going to have you write down the yellow part, but explain any scientific principles involved. For example, you might have a conclusion that, oh, I don't know, is fire a living thing? And arguments for that might be things like, well, it grows, right? And it uses energy, and living things grow and they use energy. But a scientific principle might be that all living things are made of cells, and fire isn't made of cells. And so you might say the conclusion is the claim fire is not a living organism. The evidence is it's not made of cells. The reasoning would be, according to the definition of what it means to be a living organism, you must be made of cells. See what I mean? It's that step in the middle. And that's sometimes where the real thinking happens. Now, in this particular case of the pendulum, does the swings per minute affect, or excuse me, does the distance it swings affect the swings per minute? Well, the thinking would be, if your answer is no, it does not affect it, part of your thinking might be, if it did affect it, you would expect it to have a lot more swings, or fewer swings, whatever, different number of swings when it swings a long distance than when it does a short. But as you can see, the data are very close together, therefore it does not affect it. Or the effect is within the margin of error. Like if you have one or two swings that are different, that might not make a difference. So what you want to do is mention that thinking. In this case, the thinking would be, what would you expect if it did have a difference? So you got to explain your thinking, rewrite your conclusion on the assignment. That is your assignment for this one. The first lab that you just turned in, pendulum lab number 1, basically, if you did it, you got full points, right? As long as you answered every question. This one, I'm going to grade your conclusion. So you're going to rewrite your conclusion using a CER format, using the guidelines I just explained. Okay, go do it.